Okay, 41. I do see that red 3 there. Students often confuse this with a cubing problem. And it's not a cube problem, it's a footnote. And it says, hint, hint, that's something to do with this guy over here. I don't see it. So what I'm going to do is I'm going to start the problem with, trying to do a u substitution. I'm going to say u equals the arc cosine. And this may not be helpful. And what do you get over here? Cosine of u is equal to x. I can differentiate this now. I can differentiate the u too also, but let's just do this. You're going to get minus sine of u du is equal to dx. I'm going to try to figure this out. And I'm going to say, I got an angle over here. I'm going to right triangle. Just help me out a little tiny bit. I'll say this is the angle u. This is x. That's 1. Where's that coming from? The cosine of u is just x. And what's this over here? It's 1 minus x squared. Right, so I can write this down. So it's really minus, well, what's the sine of u? It's this. All right, things kind of mixed up now, right? I got u's with x's there. And let me go back to the, what the x is. It's just cosine u, right? So I can write this as minus 1 minus cosine squared is equal to dx. And again, this could be a dead end. It may not go anywhere. And looking at this over here, I don't know, that's, 1 minus cosine squared is going to be sine squared. And, in the invertible region, I guess I can handle that. It's not too bad. It's going to give me minus sine u du would be equal to dx. All right, let's write that down. So 41. I'm going to see if I can figure this out. And our cosine of x is, I said it was going to be u. And what's dx? It's minus sine of u du. Well, you know what? I got what they said I was going to get. So let's write this down. So what's this going to be? Minus the big S, I, of u plus some constant of integration. Let's put the u back in. What's the u going to be? It's arc cosine. Plus c. Put a box on it. I want to look at the answer key. Mistakes do happen. And so it's nice to have an answer key to check it out. And am I getting it? Let's take a look. I'm not looking at the work at this point, just looking at the result. Some people say, why do you put the work down? A lot of students don't want to watch the video. They just want to, do the problem. And they make a mistake. They say, how do you get that? Then they look at my work. I would recommend looking at other people's work, by the way. It's really kind of productive to do that, to try to figure out what they're doing. There's always going to be missing steps in the work, though. Just like when I'm talking through it, there's always missing steps. That's why it's so nice to be in a classroom. If you're an attentive student, you could ask, oh, how did you do that? Where did that come from? That kind of questions. Or go to the teacher's office hours. Thank you.